Okay, guys, let's just quickly recap what we were doing. So we said that the derivative and the gradient is the same thing. Remember, we came up with this formula. We said that the gradient is equal to the gradient is equal to the derivative, right? And the derivative is this formula. Now, like we saw, this formula is on the formula sheet. Okay. So the derivative is equal to the limit as h tends to 0. Remember, h was the distance between those 2 points, right? So the distance became closer and closer to 0. So the h was tending to 0 of the function where you put x plus h in the place of x, which is what we did on the side here, minus the original function all over h. Okay, so on the side, remember I did this working. I said, okay, f of x is x squared minus 2. That's what they gave us in the formula, in the question. Then to get f of x plus h, you need to replace the x in your formula, even if there are multiple x's, guys. If there were like 3 terms, wherever you have an x, you replace that with x plus h. You then multiply out and you simplify that. All right, and I think this is as far as we got, actually putting it into the formula. Remember, when you're minusing the function, you need to put the whole thing in brackets, right? Because it was 2 terms. And then, guys, if you're looking at this, x squared minus x squared is 0, right? So those 2 terms cancel each other out. You can put that in there if you want. And then -2 minus -2, that's -2 plus 2. So those 2 are also going to cancel each other out. All right, so what you're left with there is 2xh plus h squared over h. Yes. Oh, yeah, we're not done. Okay, guys, let me find up until that point. Now, from here, what we're going to do is we're actually going to replace the h with 0. Remember that distance gets so close to 0 that we can just roll to 0. Okay, that distance between the 2 points, the h. But guys, as it stands here, can I make h equal to 0 here? No, because then I'm going to have a 0 in my denominator. Okay, so what we need to try and do, every time we have an example like this, a question like this, we need to try and cancel out the h that is in the denominator. So I'll make a little note on the side. We must make h equal to 0. And we must make h equal to 0, but we must first cancel out the h in the denominator. Guys, the way in which we're going to do that is we're actually going to factorize the numerator. Right, and that is what we usually have to do. 9.9 times over 10. So therefore, okay, if we look back at the numerator, I think we can all see that we have a common factor of h in those 2 terms. Okay, so that is what we're going to do. Guys, we still need to keep writing limit h tends to 0. I know that it's a pain, but if you leave it out even once, you're going to lose them off. Okay. What is the be a time on development that you sometimes no, unless it's like a proper problem solver. Okay, but we'll do a bunch of different types of questions. Okay, so now we're going to take out h, guys. Remember just to put your limit h tends to 0 there in front. Take out h as a common factor here. You're going to be left with 2x plus h right? If we divide each term by h, that's what we get, and that is over h. Now, guys, remember, you can't cancel out the h here at the top, right? Because here you have two terms in the numerator. So I'm worried that some of you might think, oh, nice, I'm just going to cancel out that h with that h. You can't do that. Okay, you have to have one term at the top and one term at the bottom, which is why we factorize. So that, remember, factorizing, the purpose of factorizing is actually go from multiple terms to one term. So now here we can cancel out our h terms. And what's left? 2x plus h. So guys, if I make h equal to 0, what is this going to be? 2x plus 0, just 2x. All right. So that is going to be the answer here. The derivative of this function is 2x. Yeah, I think I gave you the page. Maybe I'll check something about the flip was on it in May. Yeah. Oh, yeah. Oh, yeah, you said your mother was on Wednesday. It's on a Wednesday, yes, yeah, we haven't had our meeting yet, so I'm gonna still discuss it with. Okay, guys, we're fine with this. Is this a gradient though? 2x. Remember they asked us for the derivative of f of x equal x squared minus 2 at the point 1 negative 1. Now guys, the derivative, if you just want to add that there, remember that the derivative is always the same as the gradient. So we are getting that the gradient of this graph, of this function, remember what type of graph is this? X squared minus 2. That is a parabola, right? A curve. And what did we say the other day? We said that the gradient of a curve is different at every single point. You guys remember that? I think we wrote it down, right? We did write it down before that, the pages that I handed out. The gradient of a curve is different at each point on the curve. So guys, what we found now is we've actually found a formula for the gradient of this parabola. All right, so that is what 2x actually is. This is actually a formula for the gradient. So guys, notice that there is a variable in this formula, right? It's x, 2x. So what do you guys think I'm going to do to get the gradient of this graph at the actual point that they've given us? So in the x value, okay, it's saying at the point 1, negative 1. This is the x value of that point of contact, right, between the tangent and the graph. So we're going to actually sub in x equals 1 into this 2x, and that will give us a gradient at that specific point. Okay, so you can just write at x equals 1. I'm just rewriting the formula, right? The derivative is 2x, we don't really have to do that, but just so that we know exactly what we're working with. So guys, if we're doing at x equals 1, do you agree that I can write it like this? Okay, the derivative of x, where x is equal to 1. Right? We haven't really worked with function notation a lot, but it is going to come in more now, so I want us to get used to working with it. So it's going to be 2 times 1, which is just 2. If I could just ask us this, but let's just discuss what this actually means. Okay, we have a function, we have a parabola, x squared minus 2. At 1, negative 1 is going to be a tangent. Right? Does that ring a bell? We kind of looked at it the other day. All right, it's going to be a tangent. And the gradient of that tangent is going to be 2. Okay, so I'm going to write it down. at x equals 1, right? Or that point was 1, -1, it doesn't matter. At that point, there will be the tangent